Okay, now for the second half of scientific notation. We are just going to, I said that scientific notation helps us compare numbers and also work with large or small numbers. So now we're going to know how to work with them. One thing to note, I do not want you doing these problems on your calculator. So I've specifically chosen numbers that you shouldn't need to use a calculator for. So please, please, please do not do these on your calculator. Okay, first of all, if I have 3.2 times 10 to the negative fourth and 3 times 10 to the fifth, the first thing I'll do is I'll do the number parts together and the magnitude parts together. The magnitudes are always the 10 to a power. So I'll take 3.2 times 3, I'll deal with that part, and then times 10 to the negative fourth times 10 to the fifth. Well, 3.2 times 3 is 9.6. You should be able to do that without a calculator. The 10 to the negative 4 times 10 to the fifth. Remember your exponent rules. Those, that's a negative 4 and a 5. You're going to add those exponents to get 10 to the first. So it's just 9.6 times 10 to the first. Now how about this next one? 1.2 over 4.8 we'll deal with separately from 10 to the 6th over 10 to the negative 10. 1.2 over 4.8, that might not be completely glaringly obvious, but that's the same thing as 12 over 48. If you multiply top and bottom by 10, that's 12 over 48, which is 1/4, or 0.25. Now 10 to the 6th over 10 to the negative 10, make sure you're careful with your signs on this one. It's 6 minus a negative 10. Make sure you get that double negative in there. That's an easy one to miss. So that exponent becomes 16. Is that scientific notation? No, look at it. I need that decimal to move between the 2 and the 5. So if I make my number bigger, because 0.25 going to 2.5, that makes that bigger, I have to compensate by making my exponent one space smaller. So 16 goes down to 15. So I get 2.5 times 10 to the 15th. And please do this completely without a calculator. All right, next examples. Just another reminder, don't use your calculator. Let's say we have 1.2 times 10 to the third times 4 times 10 to the negative 2 divided by 3 times 10 to the negative 4. So we'll deal with all of our numbers together and all of our magnitudes together. So looking just at the number parts, 1.2 times 4. Don't get scared of the decimals. 1.2, think of what 12 times 4. Well, 12 times 4 is 48. So 1.2 times 4 must be 4.8. And then 4.8 divided by 3 would be 1.6. My exponents, I'd have 3 minus 2 minus a negative 4. Be very careful with your signs. So that gives me 1 plus 4, which is 1.6 times 10 to the fifth. Now let's double check. Do I have that number in scientific notation? Yes, I do. So it's working with multiplication and division of scientific notation numbers. We won't do addition and subtraction. They're a lot more involved than these are. And again, don't use your calculator. Okay, applications. The thickness of a piece of paper is 3.0 times 10 to the negative third. How thick is the 544-page book Twilight? So basically, I've got these two numbers. I need to decide if I'm going to multiply them or if I'm going to divide them, and if I divide them, in which order. Okay, I'm going to multiply these, so because if I have it's that thick per page, I'd want to multiply by 544 pages. I'm going to write 544 in scientific notation. So I get 16.32, and yes, you can do the 3 times 5.44 on your calculator, but don't do the whole thing, only the little number part. Times 10 to the negative 1, so that gives me 1.632 times 10 to the 0 inches, or just 1.632 inches. Work the problem in scientific notation, but you can change it back to a standard number at the end. The English version of War and Peace contains over that many words. If it takes you that many hours, which is that many minutes to read, how fast do you read? Now remember, when you've got these problems, it's quite often easiest to think of what the units of your answer will be, and that will tell you what you want to do. So the units, my reading speed is usually measured in, right, words per minute. So I'm going to take the number of words divided by the number of minutes. So words per minute. So 5.6 divided by 2.49 gives me 2.25. 10 to the 5th divided by 10 to the 3rd. Subtract the exponents, I get 10 to the 2nd. So I have 2.25 times 10 to the 2nd words per minute. That's great. That's scientific notation. That's great. But since we kind of want a real life, I'm going to change it to a standard number, which is 225 words per minute. You can leave it in scientific notation, though. That's fine. And I do want you to do it in scientific notation. Okay, now last question, just kind of tying the whole thing together. We decided the federal debt was bigger than the wealth of Bill Gates. How many times bigger? All right, so now I'm going to divide those. 1.104 times 10 to the 13th divided by 4.478 times 10 to the 10th. Now many calculators don't have a display long enough to contain the federal debt. So we're getting into some problems that are impossible to do. It's not just more convenient, it's actually impossible to do it unless, well, you could do it on a computer, but on a calculator, many calculators, you couldn't do it unless you use scientific notation. So we'll take our 1.104 divided by 4.478. Just the number part gives me the 0.2465. 10 to the 13th divided by 10 to the 10th. I have a common base. Subtract the exponents. I have 10 to the 3rd. So that's 2.465 times 10 to the 2nd times bigger. That's fine if you leave it like that. You could also say it's 246.5 times bigger. All right, that is the last of the applications. There will be one more video. It's just kind of a bonus. It's nothing I'd ask you to do, but I think it's a really cool problem, and it just goes so beautifully with this lecture that I had to put it in.